Welcome to Unpacked, the podcast that examines how technology is reshaping business and our world, with this season unpacking the topic of generative AI. This show is produced by Think Tank at Lab 45, Wipro's Innovation Lab. My name's Stuart Black, and I'm joined by the voice of the show, Think Tank's innovation lead, Arvind Ravishankar. Arvind, how's things today?
Fantastic, Stuart. In fact, I spent yesterday evening at the Night of Ideas in San Francisco.
All right, okay.
4 floors of the San Francisco Public Library converted into this symposium where you had artists, scientists, researchers, all coming in with different ideas of how to make the world better. It was phenomenal.
Oh, that sounds fantastic. Did you learn much?
I learned a ton. We ended up spending 4 hours there, I think. Just couldn't leave the place. KQED, San Francisco's public radio station, had a phenomenal piece. So we sat for that for almost 2 hours.
Oh, wow.
It was great. If there are listeners from the Bay Area, I definitely recommend the Night of Ideas. It happens once a year in San Francisco.
Oh, that's a very cool name, very cool idea. Sounds great, and I'm sure we'll hear more of your insights as we go. But in a few minutes, we're going to have your deep dive interview with Anupam Datta, who is a professor at CMU and Stanford, co-founder of TruEra, a company working on responsible AI. So Arvind, can you tell us a bit about this one? What is responsible AI, for example?
While AI has so many benefits for humanity, because it's so early in its development, it also comes with a host of challenges. And as business leaders work on artificial intelligence, being aware of those challenges and making sure that you are accounting for them when you develop your products, in a way, for me, is responsible AI, right? Making sure that AI does not affect humanity and our lifestyle and our progress as humanity, I think is important. And so that's responsible AI. And Anupam Datta has been working in this field for almost 15 years. He's one of the pioneers.
Sounds great. But before we get to that interview, let's look at a couple of recent stories all about artificial intelligence popping up in the news at the moment. Our first story today is a news piece about Saudi Arabia's first AI-powered humanoid robot who takes female form and is called Sarah. This has been developed by Riyadh-based QSSAI and Robots, and it marks a big step in the country's embrace of artificial intelligence, while also reflecting its conservative cultural values. Sarah has been designed using a carefully controlled LLM, and it avoids topics like politics and sex, which might be controversial over there. And she's also been dressed in traditionally modest Saudi clothing. So Arvind, what do you make of this one? What's your take?
I think, Stuart, you're going to see artificial intelligence in the back end, but you are going to see personalities in the front end going forward. What I mean by that is every AI that you interface with will take a different personality, right? And that's the power of the technology. And I think Saudi Arabia is doing the right thing where their AI is reflecting their values. And I think for business leaders, the takeaway here is that, for example, if Patagonia was to develop an AI chatbot to talk to their customers, that AI chatbot could reflect the values of Patagonia. Even though it's generic in its understanding of the world, it could actually talk in the tone, in the voice, in the brand identity of Patagonia. And for brands, this is super powerful. So I think that this has a lot of implications. For humanity, where it gets super interesting is that each of us are comfortable with certain personalities, with certain conversation styles, and AI could take that. So it could be personalized for each individual. So I think they're doing the right thing here. They are personalizing it for their needs and their culture.
It sounds great. These characters can be ambassadors for countries, for brands, but how easy do you think it's going to be, Arvind, to balance these sometimes unpredictable cutting-edge technology with cultural, traditional practices?
Actually, a lot easier than you would think, because there are techniques like human reinforced learning that countries could adopt when they work with AI that will allow them to balance the technology with their own value systems. So not as hard as you would think.
All right, well, we'll watch that space. Our second story today is a very interesting top 5 list of considerations for board members thinking about investing in generative AI. This is a kind of roadmap for those who might be hesitant given the early state of many Gen AI tools and the unpredictability of the long-term market. The top 5 are basically number 1, Gen AI's competitive edge; number 2, the likely impact on productivity; 3, maximizing ROI; number 4, what kind of governance might be needed; and number 5, what guidelines and training will need to be implemented. So Arvind, what stood out for you on this list? Did you think it was comprehensive enough? Any surprises in there?
No, I think the list covered it all, and I think at the stage where AI is in today, I think 2 of them stood out to me a little more. The first one is the responsible AI. I think it's the topic of our conversation today. So paying close attention to regulations and ethics and being responsible in how you work with AI is important. And the second one is the productivity benefits of AI. I think that's where the early fruits would be found, and figuring out how to leverage AI to increase productivity within organizations, I think is an important call out that business leaders and board members should be paying attention to.
Absolutely. And how can companies foster a culture of innovation and creativity using Gen AI tools and ensuring that they augment rather than replace human creativity and ingenuity?
That's such a fantastic question. One of the things we advise our clients these days in the world of strategy is, in the past, strategy used to be top down, where there used to be somebody, in a leadership level who would lay out the strategy for an organization. More and more today, because of how fast the world is evolving, strategy is a lot more bottoms up, in the sense that anybody in your organization should be able to influence and help you develop your strategy as a leader. And so in the case of Gen AI, opening up in a responsible manner, opening up generative AI to all your employees and getting them to come back with ideas on how can you innovate in their own jobs, how are they benefiting from it, right? And paying attention and setting up some kind of a structure to look for innovation ground up, bottoms up, I think could be a very powerful way to know where Gen AI is useful and where it's not. So, and it's a smart way to do it. I think if companies can do that, they would benefit from that.
Good stuff. So Arvind, could you tell us a little bit more about what you're focusing on in today's interview with Anupam Datta?
So Anupam has been working in the field of AI for about 2 decades. And within that, responsible AI is an area that he focuses on. So today we're going to unpack what is responsible AI, but we're also going to unpack on what is the technology behind AI. Because if you don't understand that, it's hard to understand responsible AI. So a lot of interesting conversations are going to happen on what is generative AI and what is the technology behind it. So I'm hoping that listeners will learn a lot today on this unpack in terms of the technology itself.
I'm sure they're going to learn a lot. So let's just jump in now with Arvind's deep dive interview with Anupam Datta. Our think tank focuses on researching emerging technologies that will shape your future. From generative AI to exoskeletons, we study the impact these technologies will have on business, humanity, and our planet. And through our podcast, newsletters, and social media content, we have a direct line to a truly global emerging technology community. So if you'd like to find out more about the impact these technologies will have on your business, then reach out to our team at lab45thinktank.com.
This world of generative AI has caught us by storm. As enterprise leaders and as leaders in your companies, understanding the technology behind generative AI is going to give you a competitive advantage as you plan your companies and as you plan your businesses. And to help you do this, today we're going to unpack the technology, large language models. It powers AI today, and it represents a paradigm shift in this field of artificial intelligence. And to do this today, I have a special guest. For 15 years, he taught at Carnegie Mellon on the subject of large language models, specifically on reliability and trust. and accountability. He got his bachelor's from IIT, and he got his PhD and his master's from Stanford University in computer science. After his tenure at CMU, Anupam co founded and is currently the chief scientist at TruEra, a company that focuses on AI and accountability specifically. He's authored over 300 papers and has over 9,000 citations. And these 300 papers are different versions of the core topics that he's been working on. I'm really excited to have Anupam Datta join us, Chief Scientist and co founder at TruEra. Anupam, welcome.
Thank you, Arvind, for having me. It's a pleasure to be here.
So, Anupam, today we're going to unpack the topic of LLMs. But before we do that, given your rich experience in this field, being a professor and being a co founder, and also being a student at one point, what drew you to this field of artificial intelligence?
So, around 2005, I started working in privacy. And then, in the course of the next 5 years or so, it became clear that some of the most significant challenges in that space was in the intersection with machine learning and AI. So, I started going deeper into that, and we created a body of work in this area. And in some ways, the biggest driver for me was that a bit of crystal ball gazing, if you will, led me to this conclusion that, and this was more than 10 years ago now, that machine learning and AI was going to have an impact on the world at a scale that no other technology has had. And in order to ensure that the impact is positive, doing meaningful work around ensuring responsible, trustworthy adoption of machine learning, it was more than a career choice. It was more about an ikigai moment, if you will, or a way of life that working on giving shape and definition to ensure responsible adoption of AI is in some ways been a big part of my life's work.
That's amazing, Anupam. Wipro as a company, we are founded on a lot of values, and one of them being integrity. And so, responsible AI is a core part of a lot of the work we're doing. And for you to have seen that 10 years ago and chart your career in this topic is amazing. Um, so, in this field of AI and machine learning, Anupam, LLMs have become a topic, right? And they've shown the world that artificial intelligence can become useful in everyday life. Could you talk a little bit about what is an LLM? What is a large language model?
Yeah, so at its core, a large language model takes as input a sequence of text, and based on that sequence, it generates or outputs the most likely next word in that sequence. And if you iterate on that, then what you get is a generative set of outputs, which is what you're seeing these days with something like ChatGPT, where if you start off a sentence with this podcast that Arvind has been running is, and you'll leave it hanging there, then it'll come up with the next few words. Like, amazing. So, at a high level of abstraction, the core building block for technologies like ChatGPT is this very simple primitive, which, given a sequence as an input, a sequence of text as an input, it predicts the next word, the most likely next word in that sequence. And if you keep iterating on it, the next word becomes the word after that, and you keep adding words, and you get an output, which is a sequence of text. And So that's the building block. And then you were asking about why it has gained so much attention and why now. Part of the reason for it is that over the course of the last year or so, these models have become amazingly good at generating meaningful responses. It took a very long time to train them if you start scaling up the volume of text. So that was one limitation of that generation of technology. The other limitation was that if you give it a very long sequence, then it quickly forgot. It could only remember recent context, not a very long context. Then around 2017, transformer models were introduced in this paper from Google called Attention is All That You Need. And transformer models addressed one big chunk of this problem, which is that in order to train them, you did not have to run things in sequence. The architecture was such that it was possible to, if you have a long sequence of text, you could train the different parts of the model could run in parallel instead of it all being sequential like in the previous generation. And because of that shift in the architecture, this transformer-based architecture, there was a significant step up. You could train it on much larger volumes of text. You could start scaling up those models. Now, is that a good chunk of those models use a part of the transformer architecture from before, but now they're able to get trained on, they're much larger models that are trained on significantly larger volumes of text. And that scaling, both in the model size and in the size of the data sets on which they're trained, has led to huge improvements in their efficacy. So that scaling on the size of the data on which it's trained and the size of the model has created incredibly significant improvements in the class of in this new class of foundation models. There are a few other advances also that I can get into, but maybe I'll pause here and see where you want to go.
No, this is amazing, Anupam. So three major breakthroughs, right? The transformer model, the transformer architecture was a major breakthrough. The amount of volume of data that's now available and these models have been trained on is another major breakthrough, leading to what you call this new class of large language models. Um, and also a huge host of companies now coming out with these LLMs. Um, given what you explained on how an LLM or how a large language model learns and predicts the next word, Anupam, is this intelligence? Is it a form of intelligence?
Right. So I still think of large language models as a statistical model that, because it's trained on significantly large volumes of data, and the capacity of these models is also big because of the parameter size and how much it can absorb, it has learned a lot of linguistic structure and general facts about the world. And that information can then be useful for lots of use cases. It now has the capacity to not just solve math problems, but to also surface the reasoning that it did to arrive at those kinds of solutions. I think intelligence is kind of a loaded word. So if part of your question is, does this mean that there is sentient consciousness in these models? Then, like, my view is no. It is still a machine that is learning statistical patterns and generalizing from there remarkably well. But these are machines.
Got it. No, that's really good to know, Anupam. I like that viewpoint of the statistical models that's able to generalize. Um, if you compare this to human learning, um, is this how we learn as humans too? Or do you feel like we, as humans, we have discovered a new way to teach machines how to learn?
There are some parallels. We learn from examples, as do these large language models, right? The way these models are learning is that they are being fed all the text that there is on the internet, and then they're representing what they're learning in the neural network, and then using that knowledge to then move on from there to answer various types of questions. And so the learning from examples piece is a good point where there is similarity. But there are also differences. The initial set of examples that's needed to get to that level of generalized knowledge is still way, way larger than what humans need to learn a concept, right? So I think that's a big point of difference still, that the form of learning that these LLMs have done require a lot more examples than what my 8-year-old needs to to learn to learn a concept. There are other differences, but this is one significant one in my mind. It also has some implications for this observation that maybe the current architectures we have from these for these LLMs are could be improved further, and training methods can be improved further, so that they can learn better from fewer examples. And there are some research results headed in that direction.
So are all LLMs, all large language models the same, Anupam? Today we've got a huge set of companies coming out with different LLMs. And like you said, you've got OpenAI's model, you have Google's model, you have Facebook's model, and I just learned that um, Alibaba is coming out with its own models. So I foresee a lot of different LLMs coming into the market. And without necessarily going into which one's better, can you talk to us a little bit about what is different about these different LLMs? Are they the same? Are they different? And so, could you talk a little bit about what are the differences between different LLMs? And as enterprise leaders, what should people consider when they're looking at different LLMs?
Yeah, that's a great question. So I guess there are a few different parts to your question, and maybe I'll extrapolate a little bit. So I think maybe a question that was not explicitly asked but hinted at was, is there going to be one LLM to rule them all, or will we have many LLMs out there competing in the market with not necessarily a absolute order across them? And my inclination is that it's going to be the latter, that there isn't going to be just this one model that rules them all, that we are now seeing models come out not just from the big tech companies like the OpenAIs, the Googles, the Metas of the world, but also from open source efforts. So I do think that this there's space here for a number of different LLMs, and different LLMs will end up performing better for different applications. So that's one. The second question that you were asking is about um, evaluations and comparison. And so that's an area that is actively being researched. It's an area of expertise and focus for me as well. And what we are seeing is the emergence of certain evaluations which are looking at the breadth and depth of LLM. So one way to evaluate an LLM is to say, here are 5 different categories of tasks that you may want to use the LLM for. Maybe some of them is around mathematical reasoning. Some of them is around the um, ability to reason about language and so on. And then you like solve logical problems, logical reasoning, and so on. And in each of these areas, how truthful is it? How fact-based are its responses? So in each of these areas, benchmarks are starting to emerge, open benchmark data sets, and then people are doing evaluations across LLMs and comparing them. So that's one way of evaluating an LLM, which is, I would say, like its general abilities across lots of different areas. The other way to evaluate an LLM is to get more specific. As an enterprise, if I'm building a specific application, like let's say a chatbot application or a question answering application that might be used by my customer service agents, or it might be used internally over technical documentation in a tech company, or like in the Morgan Stanley case, it's question answering that financial analysts are using to get a view on the Morgan Stanley in-house view on, say, which stocks are good investments right now and so on. So then you can turn the question around in its head and say, I have a suite of 20 applications that I'm building. Given this suite of 20 applications, for each application, what's the best choice of the LLM? Or across 20 applications, what's my best choice if I'm going to pick one or two LLMs? And so that kind of evaluation is also starting to happen now.
Got
And
it. So if you don't mind me then interrupting, Anupam, it almost sounds like um, picking the right LLM is also an art. It sounds like it, right? It sounds like it's yes, it's not a one size fits all, right? You don't choose the largest, biggest, or highest performance necessarily LLM, but sometimes you may want to pick LLMs that are better at certain tasks which are relevant for your application. So as an enterprise leader, you have to you have to bring that sort of intelligence into your company to help you understand which LLMs, right, you want to match and which LLMs you want to adapt for your applications. So should I always pick the largest model, assuming that'll give me the best performance and best value? Or is there something about also picking, the Goldilocks effect, right?
for sure, I think you want to pick the right model for your task, and that's not always the largest model. Because I think it comes back to the comment that you are starting to make, which is if I'm an enterprise leader, then I want to walk backwards from my business case, right? If you're building an application for, let's say, customer support, then which LLM to use, that question has to tie back to the value that you're going to get from it, right? And so as you vary, you can almost think of this as you have built out this application and you have a swappable place for the LLM, and you might plop in the latest GPT-4 model and then swap it out and see if you swap it in now at 3.5 GPT or a Llama V2 or Google's Palm 2, what is the impact of making those changes on the evaluation metrics that you really care about, which ultimately matter for your business, right? And then part of that equation is that the evaluation metrics also need to be balanced against cost and latency consideration. That's part of the evaluation, right? The the latest and greatest model, which is the biggest one that's out there, may not always, it also costs more. And the latency might be higher because it's a bigger model. You can look at various kinds of measurements around relevance of the, if it's a question answering system, you'll want to measure things around how relevant are the answers. You can measure things around how grounded are the answers, meaning are the answers based on a known set of facts from your personal data source that you know and trust. Um, you want to, for customer facing use cases, you'll want to avoid toxicity. You may want to care about fairness of these applications. So you can think of this as a multi-metric evaluation for your use case. And then as you swap out the various choices of the LLM and other things that you can change in your application, how does that impact those metrics along with cost and latency? And based on that, you make the choice.
Got it. I understood. I think this is really useful for leaders to be aware of, Anupam.
Yeah,
As
and
we
related to this, I guess the other point is, what are some technology differences or advances that are also helping with reducing model size, right? So when we talked a bit about the history of how we get to the current generation of LLMs, we talked about the advancement of transformer architecture, scale of data, scale of models. But there are a couple of other big advances as well. So training a chat bot, like a chat GPT or Bard, uh, and so on, it does not end with just the training, the pre-training with all the text in the world. There's also a step now, which is called reinforcement learning with human feedback, where humans are brought into the loop as part of the training. And then for a set of examples, it could be examples of questions and then the generated answers coming out of the LLM, humans provide a ranked order. And that ordering information, this preference information, can then get built into the model, and then that has led to dramatic reductions in model size. From a chatbot perspective, the interactions with humans are a lot more reasonable, are evaluated to be better. So that's an example of particular kind of human input helping significantly with reduction.
some of the things we've been debating in house are how important that step is in the future of LLMs. Because in that human reinforced learning, I think that's where you can teach the model. You can bring in your philosophy, your ethics, your own personal values, right? And I see a future where everybody may interact differently with these models and may have a different conversation with these models. And these models will be able to adapt to those conversations and personality styles. Maybe you want a model that is a little more curt, maybe you want a model that's a little more sarcastic, right? And those are possible with this human reinforced learning. Everybody has a different personality, and it's not just everybody, right? Enterprises have different personalities, right? Yes, Gap, Banana Republic, Levi's, these are all companies in the same genre, but each of them have their own personality type. And in this example of chatbots, the way the chatbot interacts with their customers could reflect the brand values. And this is where this human reinforced training method could really bring that element in, right? Not just the ethical element, but the personality of the company can come through. Could you talk a little bit more, Anupam, on for from this human reinforcement learning? What I've understood is that that caused a big difference in the way ChatGPT interfaces with people today and brought that human element into LLMs, right? GPT-3 or 3.5 itself, as a model, if you had launched it to the public, may not have had the same success as the human reinforced learned ChatGPT interface. Could you talk a little bit about that?
So what the reinforcement learning with human feedback does well is, because you have this preference ordering, and based on that, you can set up this reward function, meaning that, or reward model, meaning that if the LLM has a choice between outputting one of three different answers to your question, which path will give it the most reward? And that is informed by the human labelers. So to your earlier comment, if an enterprise wants to set up a certain kind of tone for their brand, then in that reinforcement learning with human feedback phase, they can provide examples and rank them in a way that prefers, say, a polite, formal tone or a more casual, humorous tone. It'll depend a bit on which way they want to go, and they can seed that through this human learning, the reinforcement learning with human feedback phase. And that can be quite powerful. Now, the one thing that RLHF does raise a concern about is that in some ways the preferences expressed in that small set of data, which is ranked by some number of people, can have a pretty significant impact on the nature of outputs coming out of this model. And so, can we abstract from, I don't know, 10,000 examples, 20,000 examples on which this RLHF is done? And can we come up with higher level principles that can be more broadly understood and interpreted and enforced, even while doing some form of reinforcement learning?
Actually, yeah, that's a great point, Anupam. In fact, Sam Altman, in one of his interviews, also brought this up, right? I think this was a question by the journalist on how can only a small group of people train a model that could get deployed across all of humanity, right? How can you systematize a few people's viewpoints into a model that could become the foundation? And this is where I think when you said that there would be many LLMs and not just one master LLM, I thought that was a really important statement because that ensures diversity of thought, diversity of actions, right? Um, Having a single LLM systematizing um, opinions and preferences may not be the best approach for humanity, right? You can't systematize opinions and preferences. It's got to be individual, and so this is where the idea that there would be many LLMs and many different AI models gives me personally some reassurance that the diversity is maintained.
I think that's a great point. And just thinking systematically about how to have more principle level evaluation of LLMs is important, and there's some work on it. Much like in the literature on fairness, there are 20 different fairness metrics, and they are not always consistent with each other. So you have to pick and choose which notion of fairness to ensure of your systems. For other kinds of values as well, thinking through how to have a space of possible options and then express that in a way that's interpretable and enforceable at the model level. And since we're starting to get into some of the pitfalls, maybe this is also a good segue to pointing out that increasingly LLMs are not being used just in isolation to solve enterprise problems. They are being augmented in various ways. So, for example, one kind of application that is getting a lot of adoption and currency is this retrieval augmented generation kind of applications, where you don't use the LLMs in isolation to build a chatbot or question answering system. You augment it with a knowledge base or source of truth. So if you think back to the Morgan Stanley application that I brought up earlier, Morgan Stanley was trying to build an application using which its financial analysts can get advice on what stock to invest in or how to construct a portfolio and so on. But they didn't want an LLM like a GPT to be the source of truth for these answers. This GPT has been trained on a whole bunch of stuff on the internet. Instead, they put together a knowledge base, which was 100,000 documents of their research reports, financial analyst reports, and so on. They put that into a database. And in this space, vector databases are getting wide adoption from Pinecone, and there's a bunch of others, Chroma and Viviate and Milvus and so on. And then you take these documents, you convert them into what are called embeddings, then you put those into the vector database, and then the LLM is used for certain tasks, but not everything. So the way the process works then is let's say an analyst asks a question like, is this a good time to invest in Google? That question gets translated into a database query in the embedding space. It gets run against the vector database, which has Morgan Stanley's source of truth. And then from that database, let's say 10 analyst reports are retrieved as the most relevant to that query. And then that is then summarized by the LLMs in the final stage to produce the final summarized response. So if you think of this process, it helps with a big challenge with LLMs, which is hallucinations. They make stuff up. And in some ways, that's what they were trained to do. They were being trained to generate plausible sounding text. So it's not surprising that when you start asking very specific kinds of questions, they can make stuff up. But the vector database then serves as a knowledge base, which as an enterprise, you can put in information that you trust, and then that becomes the source of truth against which the final responses can be evaluated. But even when you augment LLMs with a memory store like a vector database and create these kinds of applications, challenges still remain. You can still get hallucinations. The final responses may not be relevant to the question you're asking. The final response may not be grounded in the retrieved context from the knowledge base, meaning it may not follow immediately from that. And so these are all failure modes that you want to have evaluations around to catch, debug.
Got it. I love this. Love this, Anupam. I want to unpack this a little bit and discuss it in two parts. The first one around the pitfalls, which is that because these are statistical engines that are generalizing, there are times where they will have improper combinations and provide and hallucinate, right? What you call hallucinations. And grounding them in that vector database prevents those hallucinations. Um, and I think we're going to do a whole episode on grounding here soon. So I think you're setting up the stage for that really well, and it's an important point, and we'll definitely dive into that. There was a second thing you mentioned, and I want to dig into this, the second part of this, which is that when you ground these LLMs in that vector database, and I think the word you used was a retrieval engine, right? So the way we need to look at these statistical engines then is, or models, is a way for human beings to see if there is existing knowledge that they can tap into in a particular topic, right? So for example, in the case of should I invest in Google stock, when the LLM goes back and searches through its database and puts things together, it is retrieving from a past set of human knowledge that existed to give you an input, right? It and so the way I look at that is, if I need to make a decision, has there been precedence or is there intelligence I could use out there to help me make the decision? Um, and that's the retrieval side. Now, do you think that the same statistical models can also be used towards ideation? in the sense that no past human knowledge has existed in a particular area. So, for example, let us say that you want to synthesize a new chemical, or you're looking to develop a new material altogether. Um, can LLMs and those statistical models be used in those applications? Or do you see them more in the sense of tapping into past human knowledge to educate us?
Yeah, I think generative ideas are very possible with using deep neural networks in general. And there have been some success stories in the specific use case you're talking about, which is uh, in generating in some of the drug discovery kind of areas where um, coming up with new ways of uh, creating proteins and things like that. So I think the short answer to your question is yes. There is opportunity for generative. It's quite literally a generative engine. So it's meant to come up with similar looking things to what it has seen in the past, but not necessarily identical to what it has seen. So it can be useful for various generative activities. And we are seeing that in lots of use cases that are relevant to enterprises as well, right? So if you think about writing marketing copy or writing sales outreach emails and kind of managing sequences of outreach that a sales team and SDR team might be putting out, those are generative activities. And we now have several pretty significant companies in that space that are working on those problems. Healthcare is a whole other space that will benefit from the advancement of these technologies. But the broader pitfall that I highlighted still needs to be kept in mind, which is as these generative outputs come out, don't necessarily view them as the right answer, right? So if it's in a drug discovery use case, there's going to be like chemical chemists and such who will validate the results, right? In the digital world, we also need to have careful validation and evaluation, monitoring, and so on to make sure that we have those guardrails where we don't just take the generative outputs as truth.
No, I think this is a very important point, Anupam. And so maybe you can talk a little bit about what are those guardrails? How should enterprises think of those guardrails? And today, are there tools, are there companies they can work with that understand these guardrails?
Yeah. So the way we think about this is as you are building out your models and applications during the development stage itself, you want to have careful evaluations, testing, debugging in place to check for a broad range of required quality attributes, if you will. So, for example, for large language models, you want them to be helpful and harmless and honest. As you're building out question answering systems, how do you ensure that you have groundedness? How do you ensure that the answers are relevant? How do you ensure that they're not toxic? How do you assess for fairness? There's a broad range of evaluations here, and you'll want to do custom evaluations based on your use case, ensuring, for example, brand tone. And so I think an evaluation framework needs to be very broad and extensible. So it needs to have some of these core pieces that I just touched on, but also it should be easy to add additional evaluations and simple tooling to do that. And you want to carry that into production. So let's say you have built your app, you have evaluated it, you found a bunch of failure modes, you address those, and then you move the model into production and along with the application. It could be a chatbot, it could be a question answering application, it could be one of these agent based frameworks that involve LLMs but are augmented with external APIs that could impact the world. Like, say, you build an application that lets someone very easily plan a vacation and book travel and hotel reservations and so on. For each of those applications, as you are building them, you want to build out these tests and evaluation metrics along the lines of what I shared, and then carry them over into production so that you can monitor on the new data. Is it still doing well? Or are there failure modes that you need to catch and address? And make that whole life cycle observability support. So that's something that we do at TruEra and support, and it's an active area of development and growth. And we have put out an open source library called TrueLens that we're engaged with the community and building in the open, which I think is extremely important to do in this space because there's such a fast moving pace in the field. And building as a community, bringing in the best ideas is extremely important to do right. And some pieces of these evaluations, especially on the model side, is something that the model providers themselves are starting to do.
Yeah, it's amazing, Anupam. I also encourage our listeners to check out TruEra, the company that Anupam has co-founded in this area of responsible AI. So Anupam, it almost sounds like to me that as companies think about how to how to leverage the power of these statistical models, they also have to set aside investment on evaluating them, on testing them and observing them, right? It's not don't think about your investment only from the standpoint of, I got to develop the best features and functionality and release it to market. Because of how early LLMs are in their journey, you also have to set aside money, at least in the next couple of years, on the testing, observability, till we get to that point where we know that they are reliable and they're producing the type of output we're looking for. I think that's a very important call out, and I hope our enterprise leaders and listeners pay attention to that call out to set aside investment, not just for the development of AI, but also its testing and observability.
And education of the workforce, because it's
And education of
vastly
the workforce.
different.
That is right. Absolutely right. Before we close out our episode, over the next 6 months, for our listeners, what are two or three key things they need to keep in mind as they build out LLMs, as they integrate LLMs into their businesses, and as they deploy LLMs into the world? What are a few things that you think an enterprise leader should have top of mind as they work in this area?
Yeah, I think, and some of this, the forward looking enterprises are already doing. One is to start with a clear business case, use case, application that has value. And we're seeing a lot of activity in the space around question answering and chatbots and agent based applications. But once you have the business case for the application clear, then working backward from it to see, here's what we are building. So I think one of the shifts we will observe is in the next 6 months, a, a good chunk of early adopters will have LLMs and LLM applications move from the development and experimentation phase into production. That's something, and that move has to be done very carefully, because you'll want to have infrastructure for experimentation, which many folks are now in the process of building and acquiring. And then moving into production is another set of infrastructure related tools. So I think that shift is something we'll see in the next 6 months. And I think doing this carefully in a way that you have these guardrails in place for evaluations and production monitoring. The full life cycle of observability, if you will, is going to be extremely important. And then the final thing I will say is that the education of the workforce, as there is this phase shift in the technology, is going to be extremely important as well to really get the value from it. This will require some amount of learning new things or a new way of doing things, because the technology stack for machine learning is changing so dramatically. So those are the three things I would say. Start with the business use case and have some clarity on where the value is, so that whatever evaluations you have and ties back to that. And then the second piece is around this shift from development to production and the importance of having evaluations and monitoring full lifecycle observability. And the third piece, in my mind, is around education across the company, all the way down from the leadership to the builders, to ensure that it's done in a way that's effective and responsible.
Well, thank you, Anupam. Appreciate that. Thank you for spending the last hour with us. It's been a very educational, enlightening conversation. And I look forward to hosting you again, maybe in a series 2 of our podcast at a later point in our series. Thank you once again. And for our listeners, we will have links in the podcast episode that tie back to some of the papers Anupam has published. We'll also have links on some of the papers we publish on Lab 45 on foundation models, LLMs. There's a paper called the AI Paradigm Report that I encourage you to go read. And it'll touch upon some of the topics that Anupam has brought up today. And I look forward to seeing everybody in the next episode. Thank you so much. Thanks, Anupam.
Thank you, Arvind. I appreciate it. It was a pleasure.
Arvind, great interview as ever. Can you highlight some of the key points that you think we should all be focusing on?
Absolutely. I think Anupam did a great job in explaining a lot of important technical concepts, right? So a lot of us understand generative AI today in a very broad level, and he unpacked what the technology really is and how business leaders can leverage it. So there are four key areas I think that are important to summarize all his insights. The first one is, what is the technology behind generative AI? And the second one is, how is the technology different from human intelligence? He dove a little bit into that, which is super interesting. And what are some considerations as you use this technology? And where should you use the technology, right? Those are four broad areas he covered. So, in the first one, in terms of what is the technology, um, the foundational technology behind generative AI is large language models trained using transformer architecture, right? And these LLMs are what's responsible for ChatGPT and a lot of the other technologies that you're seeing in the AI world. Now, how is the intelligence of LLMs different from human intelligence? Um, LLMs learn similar to us in that they learn from examples that they see in the past, right? That's how they learn, which is also how human beings learn. But the difference is that even a kid needs few examples to learn something, but LLMs needs a lot of examples to learn, right? So they're a lot more far behind than humans in how quickly we learn and how adaptable we are in our learning. But they will catch up one day, right? So that's the difference between AI and humans in a nutshell. Now, this is from the angle of intelligence, but intelligence itself falls in many different categories. The third one is, where do you use LLMs and how to use them? Is there a one size that fits all? And I think the key takeaway there is that there is no one size fits all. Business leaders need to hire the right talent inside their organizations to know which LLM to choose for their application, right? Latency, cost, accuracy, like we discussed, personality types, right? Each LLM could be trained to be a little bit different in how it answers questions, etc. So having someone in your organization understand that, or working with an organization such as Wipro who understands that really well could help too. The last part of this is, where do you use LLMs? And I think he summarized it really well. Today, most areas where you want to use LLMs are retrieval based use cases where the LLM has to retrieve some information and give it to you, right? Which is why search is such an interesting area for LLMs. So if you think of retrieval based use cases in your business, I think that that would be a really interesting way to quickly bring value, and also interesting way to improve productivity, which is what was spoken about in the earlier news article. So I think those are some of the ways in which you could use it. And for deeper information, I recommend business leaders to go back and listen to the episode.
I'm sure they will do, and me too. Lots to learn there. So thanks for summarising that for us. And that's it for today. Thanks as always to our guide through this interesting world, Arvind Ravishankar.
Thanks, Stuart.
If you like our podcast, please like, subscribe, or tell your friends. I'm Stuart Black, and see you next time on Unpacked.